Hello everyone. Today I'll be explaining one of the most important concepts in machine learning, how we split data into training, validation, and test sets, and why cross validation is used. These ideas form the foundation of building reliable and trustworthy ML models. So let's start. In machine learning, the way we divide our data is extremely important. A smart data split prevents overfitting and tells us whether our model will actually work in the real world or not. So let's break down on how each part, training, validation, and testing plays its own role. Okay, so training set, building the brain. Training set is the biggest part of the data. This is where the model learns. It is where it finds pattern, adjusts weights, reduces errors, tries to understand the relationships between features and outputs. Usually about 70% or more of the data is used for training. You can think of it as model's classroom. This is where all the learning happens. हेलो. गुड मॉर्निंग मैम. मैम मैं अभी घर पे हूँ. हेलो. Yeah. Training set, building the brain. The training set is the biggest part of the data. This is where the model learns, it finds patterns, adjusts weights, reduces errors, and tries to understand the relationship between features and outputs. Usually, about 70% of more of the data is used for training. You can think of it as model's classroom. This is where all the learning happens. Validation set, fine tuning. After training, the model is not ready. It might be overconfident or may not be generalized well. The validation sets help us fine tune the model. We use it to tune hyperparameters, compare multiple model versions, prevent overfitting. It acts like a rehearsal between the final performance, before the final performance. Now the test set. The test set is like the final exam. The model should never have seen this data before. We only use it once after training and validation are done. To measure how well the model performs on completely unseen data, this gives us a fair estimate of how the model will behave in the real world. Now, cross validation beyond a single split. Sometimes a single training test split is not enough, especially when the data set is small. That's where cross validation comes in. We divide the data into k folds, train on k1 folds, and test on the one remaining fold. We repeat the k times so every fold gets a chance to be the test set. In the end, we take the average score. This gives us a much more reliable performance measure. Now, the k-fold cross-validation. The dataset is split into k equal parts. We train on k1 parts. We test on the remaining part. Repeat until each part has been a test set once and take the average performance. This makes results more stable, reduces the luck factor of a single split. Now, cross-validation versus train validation test split. So when should we use which? Train validation, test split? Very simple, faster, works well for large data sets but can be biased if the split is unlucky. This is when we have to use train validation या फिर test split. Now, cross validation. We need to use cross validation when it is more reliable, uses data more efficiently, great for small or medium data sets, but more computationally expensive. When to use each approach. To summarize the practical use cases, use train validation test split when dataset is large. You want quick experimentation. Use cross validation when dataset is small. You want stable, trustworthy results. You are doing final model evaluation. The key takeaways are to build a strong ML model, train the model to learn patterns, validate to tune and avoid overfitting, test to measure real world performance, cross validate to get more stable and accurate performance score. Using these steps correctly leads to better, more reliable machine learning systems. Now, why this matters? Finally, why this is so important? Because a model that memorizes the training data is useless. We want models that generalize, models that perform well on data they have never seen before. Proper data splitting helps us avoid overfitting, reduce evaluation bias, choose the best model, build trustworthy ML solutions, and that's the core of responsible and effective data science. So, yeah, I hope this made the concepts of training validation, test sets, and cross validation easy to understand. These techniques may seem simple, but they are essential for every ML project. I hope you like my video. Thanks for watching. See you soon.